The population of ants doubling every month. A bank account earning 5% every year. These are examples of exponential growth, which occurs when the amount at each stage is multiplied by a number greater than 1, like 2, 4, 8, 16, 32, or 3, 9, 27, 81. So exponentially increasing. And the graph of the exponential function, we will talk about directly, let me tell you right now. Their graph are in the form of this, something, let's say, for example, here, okay? And by the way, linear functions are, in this way. It's a straight line, but exponential function in this way. For example, 2, 4, 8, 16, but linear 2, 4, 6, 8. So difference between them like 2, 2, and 2. But here we have 2 to the power of n. Exponent, this is the base, and this is the power or exponent of the numbers. 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and so on. Okay, the most important thing for us, dear students, here, in the case of ants, this number is 2. In this case of bank account, it's 1.05. Why? 5% every year means first year you have 1, second year 0.51 plus 0.5, which will be 1.05. And then other year 1.05 plus 0.5 of this, and so on. Now, most important thing for us, let me clean. I don't want to confuse your mind. This expression, we have to be familiar. What is the expression? This one. Y is equal to, y is equal to 8 times x to the power of t. Now, this is the form of exponential growth. Form of exponential growth. What does it mean? Here, a is the initial amount. So at the beginning of the action. So let's say initial value. And here x is the rate that we multiply by. So x is rate and t is the time. We will see the exercises. Now, so we started off 100 ants. Our equation will be 100 times 2 to the power of t. Since it says there, where was the example? In the case of 100, this number is 2. Bank account examples occurs, blah, 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 blah. Let's pass this. Bank account is, okay, for the bank account, let's stop. Let me clean this part again. So the bank account question is this. It says that you have a bank account and it earns 5% every year. So if as an initial you have $100, that means in the second year it will be 105. So how can I express this? 1.05. Why? 5% we have. 5% means 0.05. 1 plus 0.05, which is 1.05. So in the formula, 1.05, it's being x, which is our rate, and then 200 is our initial amount at the beginning, what we have in our pocket, and t, how many years later, how much we will get totally, we will see. Now, exponential growth, something like that. So the x values are growing. By the way, y values are growing rapidly, very quickly. So y values are getting bigger and bigger very quickly. Now we will see the exercises, the samples, and you will understand better, I am sure. Now, notice now the graph creeps up slowly at first, and then shoots up to faster and faster over the time. That's the exponential growth. Now exponential decay. What is exponential? Decay means something is decreasing, okay? Now, however, it's opposite of exponential growth. So growth and decay, opposite things. Imagine a radioactive element that loses mass over time. So this is one chemistry topic. Radioactive elements are losing their mass when the time is passing. It loses a lot of its mass at first, but then loses it more slowly over time. So At the beginning, very quickly, okay, decreasement we have, but later on, it's being slowly. So at the beginning, there's a quick decay, quickly we are getting down, but later on, slowly we are getting down. So there is something here, what it says. Memorize the shape of the graphs of exponential growth and exponential decay. So what was it? This is now exponential growth. Something is increasing. And this is now exponential, let's say, decay. Okay, let's be familiar. The SAT will test you explicitly on them. The equation of exponential decay, it's same as the equation for the exponential growth. So we have only one equation, a times x to the power of t. The only difference, the rate. So the rate is different, is less than 1. So when we have something is increasing, x, which is rate, is greater than 1. If x, which is rate, is less than 1 and greater than 0, this is decay, okay? Decreasement, this is growth, which is increasement, growth, whatever. Now, example, where y is the final message. So we have a radioactive element. At the beginning, amount is 400 gram, kilogram, or I don't know, ounce, whatever it is, but it's at the beginning 400. And it is decreasing 40%. Decrease 40% means 0.04 decrease. So if your initial point is 1, so when you decrease something 0.4, so it will be 0.06. So our rate will be 0.06. We are not writing rate is 0.4. So if something decrease 40%, we don't say this is 0.04. We subtract from the 1 and we write our rate. T is the time. We will see the exercises again. So just we are talking a little bit theoretical part right now. When you see the examples, everything will be clear. Now, second example, it's something different. It's a linear growth. So exponential we have seen. So what was the graph? Something like that, or graph something like that. Okay. Now linear growth. So this is decay, and this is growth we said. Now linear growth means it is growing, but not as quick as growing exponentially. So it's like a straight line. The line is there's a constant slope. So let's see it. For example, if Anne has a piggy bank with $50 already in it, and she adds $10 every month. So you have $50 in your bank account. Sorry, not bank account. It's piggy bank, which means piggy bank means, by the way, it's a you making like a box. Okay, you are saving your money. You are putting your money there. It's not a bank. It's not giving interest. Okay, just to keep it, to store your money. Piggy bank. You know, every kids they have in your early childhood. Now has a piggy bank with $50, and she adds $10 every month. So first month I am adding $10, so it's being $60 in total. Second month, I am adding another 10, so it's being 70. Third month, I am adding another 10, it's being 80. So 60, 70, 80, 90, like that. 60, after that 70, after that 80, after that 90. So slowly, in the same ratio, okay, in the same amount, it is increasing. So this is called linear growth, okay? But again and again, I want to tell you what is exponential. It was something like that. So very quickly, you see now. So these differences are here same, but here, of course, they are not same. This one, this one, this one, this one, this one, this one. So quickly it goes up. What it says, unlike the exponential growth, linear growth doesn't have moments. moments when it slowed down or speed up. Growth, it's constant. It goes up by the same amount each time. So for the linear, we have the same amount, something like that, for example. Now let's go on. It's a little bit theoretic, I know, but we will start the samples. So what is linear decay? Same thing, but opposite. So imagine in your piggy bank, okay, you have a $50, but every month you are taking and you are spending this money. So after the first month left 40, after the second month left 30, after the third month left 20. So every month you are taking $10, you are spending $10. You are not putting, you are spending. And so what's going on then the graph? Graph is decreasing, 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 and when times cut comes, it will be zero. So T time, and let's say here y, which is amount of money, amount of money. So the money is decreasing when the time is passing. We call this linear decay. Okay, now another important topic in SAT, positive or negative association or strong relation. What is that? Let's have a look. Both exponential decay and linear decay are examples of negative association between two things. What does it mean? When number of absences increasing, the final mark decreasing, or when the time is increasing, money is decreasing. So there is a negative correlation, negative relation between these two things. Okay, what about the positive relation? For example, it says that how many lesson hours you are studying in math exam, your success is getting larger and larger, for example. So, or how many students are involving one school, the school income is getting more and more for every student. So when X values are increasing, Y values are also increasing, and there is a strong relation between them. There is a positive association between these two things. So one more time, when something increase and the other thing is increased both, we have positive association. When something increase, the other is decreased, or when something is decreased but the other is increased, we have a negative association between the things what we are talking. Finally, let's talk about the questions. Okay, the first question is this. Calculator, it's not allowed, it says. Now, if the initial population of rats was 20, so at the beginning 20, grew 25 after the second year. So the first year, we have 20 rats, and the second year, we have 25 rats. So I want to ask you, what is the rate of growing here? In what rate it is growing from 20 to the 25? What is the rate? Can you answer this question? How can we find this? If you remember, new value minus old value divided by old value times 100 gives us the percentage increase or percentage decrease. So in this question, chat screen, I am looking chat screen, 5 each year. Okay, very good, very good. You already answered the question. Okay, so what can I say then? It's so clear that from 20 to the 25 after the first year, we have a 5% increasement. Okay, 5%, which means 0.05. Now, let us continue. Which of the following function best models the population of rats P with respect to number of years T? The population is growth of rats considered to be exponential. So it says that this is exponential growth, exponential growth. So what is the formula? So the thing is we should just keep in our mind, y is equal to a times x to the power of t. A times x to the power of t. Okay, so this is the exponential growth. And so in this case, y means in my question p, and a is initial value. So at the beginning, initial value is 20 times x. X is rate. So since this is increasing 5%, so original is 1, 5% increasing means 0.05. So it will be 1.05. That means 1.05 I have to write here. And in how many years? It says t years. So I put here t. So the answer of the question will be B. Do you have any question till now? And do not forget, please always use decimal numbers. Even the interest problems, compound interest or the simple interest, we always use 0.05 or 1.05, something like that. Usama, any question?
Yes, Mr. Why it's written 1.25, but it is 1.05?
I just explained one more time. Let me explain. One more time. Let me explain. One more time. So, when we read the question, we should be careful. The question says, this is growth and exponential. So you want to write, question says that write one equation, which is exponential growth. So my question is this, what is exponential growth? I just explained at the beginning of the lesson. Exponential growth is an equation in the form of y is equal to a times x to the power of t. A is initial value, x is rate, increase or decrease, how is increasing or how is decreasing when the years passing, and t is time. So you are maybe asking this one, teacher, why not 0.05? Why 1.25? So by default definition, it says that you have at the beginning 1, always, even increase, even decrease. Initially, you have 1. 1 means 100%. 1 means 1 over 100%. So since from 20 to 25, after the first year, number of rats are increasing to 25. So I'm asking that, what is the rate? It is 5%. Do we know how to calculate this? Do we know how to calculate this?
Yes, we put the decimal 0.25.
25 minus 20 divided by 20, 5 over 20, right? Yes, no?
Yes.
And then 5 over 20, how to multiply by 100 if I say, so 0, 0, 10, 5, 5 times 5, 25, so 25%. So how can I express 25%? 25% is 0.25, okay? So 1 plus 0.25, which will be x, which will be rate, 1.25. That's it. This is the x. And in the formula, when I substitute here, initial value, which is 20, the rate is, which is 1.25, and the time is t, which is t. So this is being the answer B. Is it okay now or not?
Yeah, sir, thank you.
Sure.
Yes.
I can try another time. If not, you said it's okay. Good. Let us continue. Let us continue. Now, for question number 2. For question number 2, let's solve now. If the initial value, if the initial population of pandas was 100 and grew 125 after the first year. So from 100 to 125, what is the increasement? How can I find? 125 divided minus 100 divided by 100 times 100. So it will be 25%, right? That's okay. So what is the rate? By the way, I didn't finish the question. Let us finish reading the question. Which of the following function best models the population of panda with respect to the number of years t? Population growth pandas, now linear. It says linear, dear students. Linear. Linear. What is a linear? Y is equal to ax plus p, or y is equal to mx plus p. It's a straight line. So we have to write one equation in the form of line, not now exponential growth. Since question says this is linear, then I am thinking that how could it be? Let's think together. Let's think together. The logic is very simple. Then we can formalize. Initially, at the beginning, I mean, you have 100. After the first year, it is being 125. That means 25 we are adding. After the second year, plus 25, it will be 50. After that 75, after the 200, blah, blah, blah. So how can I formalize this? How can I write one formula? Firstly, my initial value is 100 plus 25 plus 25 plus 25 plus 25. I am adding just 25, 25, 25. How many 25? After first year, 125. After second year, another 25, but totally it will be 2 times 25, which is 50. So 100 plus 50, 150. After the third year, another 25, but when I compare initial and after the third, it will be 325, 25, 20, 25, which makes 175. So it is clear that at the beginning I have 100, and then each year, if I call the year t, each year it's getting 25 extra. When t is 1, it will be 125. When t is 2, 2 times 25, 50, 50 plus 100, 150. When t is 3, 3 times 25, 75, 100 plus 75, 175, which is I already explained here. That means the formula works. So do I have anything this formula? Let's check. Part A. Yes, part A. Since question says this is linear growth, we use this formula. If the question says this is exponential, I have to use this 100 times 1.25 to the power of t. If question says this is exponential, but question says this is linear, for that reason, I use this one. Am I clear?
Mr.
Yes.
You can see from the question it says linear without solving. If you want to save time, you can see the form of the like the options. Like look at A, it's the only one that satisfy linear because it's
You are right.
mx plus b.
You are right. This is the test technique you are telling to me. That's right. It's very good. So as you said, when we look at here, this is exponential. This is exponential. This is quadratic. We haven't studied, but from the algebra, you know, second degree. So just the linear is this. That means directly solution is this, directly, without any calculation. Test technique. You mean this one, right?
Yep, exactly.
Yeah, thank you so much. Very good.
Well,
Now let's go to question number 3, dear students. Question number 3. What can we say about question number 3? Can you try the question number 3 by own? Or let me explain, we can solve the test questions later. Let me explain the question number 3. Let me explain question number 3. First of all, the population of trees in forest has been decreasing. So not increase, now decrease by 6%. So 6% decrease. Every 4 years, be careful, not every year, every 4 years. So if, okay, let me continue reading. The population at the beginning, 2015, was 14,000. If P represent the population of trees in T years after 2015, which of the following equation gives the population of trees over the time? So which one is correct? First of all, the population of trees in the forest has been decreasing. by 6% every 4 years. The population was at the beginning 14, and what will be after after 2015? It says, right? Let me read one more time. If they represent the population of trees T years after 2015, okay, after 2015, T years later, which of the following gives the correct one? First of all, let us decide together. This is linear or exponential. This is linear or exponential. Any answer? Any comment?
It's exponential because every 6 years it decreases from the original amount, which is 14,000. So
Every 4 years, not 6. Oh, but okay. So it is decreasing 6% every 4 years. So this is not linear, right? Linear means each year we continue, and not as a percent, as a fixed amount, like 20, like 30, like 2, amount, pieces, not percent. When you talk about a percent, something is being different. Okay? Look at for example the question, where was it? Here in this question, from 100 to 125, but actually in this question there could be two choices. Even linear, the question is not so clear, since the question says that just 1 minute, my battery computer, just 1 minute. Okay, right now. So it is not linear, it's exponential. When something is in terms of percentage, we may think this first. Okay, if this is exponential, what is the formula? Even for decay, even for growth, both of them, formula is a times x to the power of t. If x is greater than 1, it's a growth. If x is between 0 and 1, it's a decay. We said exponential decay or exponential growth. Now, the rate is, if it's growth, 1 plus this increasement as a percentage. If this is decay, same thing, 1 minus, we have to think, 1 minus. So what is the percentage? It says decreasing by 6%. So 1 minus 0.06, I have to say. One more time, I want to underline. If it says increase 6%, I have to say 1 plus 0.06. Since it says decrease, 1 minus 0.06. 1 is fixed, always we use. Why? This is a total amount. This is like a 100% is 1. Okay? And then times initial value, which is A. So initial value, it says 14,000, which is here. Now T. But here, be careful. The problem is this here. For each year, we are taking T is time is T. The period is T. For each time period, when we talk about this is T. But in the question, something is interesting. It says every 4 years. Not every year, every 4 years. For that reason, we have to divide by 4. We remember last week we have talked about the compound interest problem semi-annually, we said. So it was 2 times a year, similar to this logic. Since this is being every 4 years, 6% is increasing. That means 1 year, just 1 year, T over 4 must be in the formula. Okay, one more time. Each year T in the formula, each year T. If it is different than 1 year, if it says 4 years, we have to divide by 4. So when I check this, T over 4 here, T over 4 here, this is 4T, not possible, 4T, not possible. So first or second, which one? 1 minus 0.06 will be 0.94. For that reason, the answer is D. Check it one more time, please. Question and the solution. Osame, yes, you can ask me your question.
I didn't get why it's t over 4 and not 4 times t. I didn't get it. Can
One
you?
more time.
No, just why it's t over 4 and not.
Okay, one more time, let me explain. One more time, let me explain. Let's go now, the formula. Formula T, T is number of years. Each year, this increment we have. Let me explain now here. Okay, one more time. 0.06, which means 6%, decrease is being, but not being each year, not every year, not every year. It is being each 4 years. For example, 2014 or 2015, 2016, 17, 18, nothing, 1, 2, 3, but 2019, so it was, let's say 100, but it is being now 94. When? After 4 years. My formula, which is y is equal to a times x to the power of t, this t refers each year to use this formula. When I go 15 to 16, 16 to 17, 17 to 18, 18 to 19. But in my formula, increasement or decreasement, actually in this question, decay, so decreasement, it's not being after the first year, it's being after the 4th year. So this amount, 6% decreasement being after the 4th year, not after first, not after second, not after third, after the 4th year. So in the formula, it says that this is for every year. The formula it's used by every year. Since this is not every year, it is for 4 year. Or simple logic. If for 1 year t, for 4 years, what will be? There could be two things. If there is a direct proportion, 4t. If there is an inverse proportion, t over 4. Am I clear? Direct and inverse?
Yes.
Direct, indirect. So let us think, this is direct or indirect? Time is passing, time is increasing, population is decreasing. So this is direct or indirect?
It's indirect.
Indirect. That means we have to use t over 4. Okay?
Okay, so Mr. What I understood, like the logic behind it is, as the person, يعني, each 4 years, the amount of 6% is less.
Yes.
That's why we. Okay.
That's clear. Or
Yeah.
if you want to use just t, you have to change this amount, this 6. So you have to divide by 0.06 divided by 4, something different.
Okay. Thank you.
Okay. By the way, I hope I will not have a problem with my charger. It charges and it's not charging, charging and not charging. Let me check one more time cable, sorry. Okay, I get it. Let's plug out. Now, let's go down. Let's see the examples. So you will solve and you will understand better. Yeah, simple question. Even in statistics, I mean, statistics part of the SAT, you can see this kind of question. Which scattered plot shows the strong positive? Strong positive means, dear students, this. Linear and increase. Linearly increasing something. Or let's say linear growth. Linear growth. So when you look at alternatives here, which one seems the linear growth? First of all, this is decay, which means decreasing. So it's not possible. Here, increase or decrease, I cannot say anything. It's mixed, right? I can't say anything. But here, it's increasing. And here also, it is increasing. When you look at these two graphs, which one is strongly increasing? This one or this one? A or C?
C.
I think C, right? So normally we solve this kind of question. We draw y is equal to x line, which is passing through origin. So the points are more close to this line. It's always better than, for example, like this. So this is the best line. So something is close to y is equal to x line. This is the best approximation. This is the best matching. So in my question, increase, yes, but most of the points are close to y is equal to x here, but here no. Here no means even like that. You know, some points are the difference between this length and here when you draw the length. So the length between y is x and y is x, when you compare, this is bigger. So bigger means it's not acceptable. We want to get exact things on the line. So the answer of the question is part C. Okay, let's look at the question number 5. Can you solve and write the answer to the chat screen? Okay, guys, 2 answers I got. The others. I'm waiting. You write to chat screen, please. Okay, good. Very good. So all of you say the same thing. All of you say this is exponential growth. Let me look at. I didn't read the question. Let me look at. So, okay, 3 at the beginning and got $6, so $9, $18, $27, $54, $81. I mean, first day, we have this. Second day, we have this in our pocket. Third day, we have this. Fourth day, we have this. This is easily 3 to the 1, 3 to 2, 3 to 3, 3 to 4. So a to the power of n is exponential growth. So the answer is C. Bravo. That's good. Super. Now, question number 6, please have a look. Question number 6. And write to the chat screen. Esma said something. Okay, others. Osama said. Okay, I'm waiting the others. Only 2 answers I got. Okay, very good. So you said answer is B. Okay, yeah, the answer is B. Why answer is B? Is it clear? Do we need explanation? Time is passing. Number of books are decreasing. Time is passing. Number of books are decreasing. So, okay, let me explain one more time. Albert has a large book collection. So someone has a book collection. So this is our library, for example. In the library, there are books. We have books, okay? Now it says that he decides to trade in to trade, you know, to sell, let's say. Boys, I don't want to send anyone to out. Quiet, please. Now, 2 of his used books for 1 new book. So he will give 2, but he will take 1. So he will give 2, he will take 1. That means when the time is passing, 2 books he is giving, 1 book he is taking. That means the number of books are decreasing. So time is increasing, but number of books in the library, let's say, decreasing. So something increases, something decrease, or when the time is increasing, the number of books are decreasing. This is better. When the time is increasing, number of books are decreasing. First of all, it must be decreasing or decay, one of them. It should be decreasing or decay. Decreasing or decay, how can I understand? So for each 2, 1 I have. Each 2, 1 I have. That means the difference will be -1, -1, -1, -1, -1. That means it's a fixed amount, not like 3, 9, 27, 81. It is not exponentially. So it is linearly decreasing. So decreasing and linear, the answer is B. You are right. Good. Most of you did. What about C? What about C? Let's try to get C. Someone said D. Okay. I'm waiting the others. Aisha said okay. Good. That's good, Aisha. Okay. Most of the answer is D as I see. Okay. The answer is D. That's correct. So